In the next question, so we have electronic structure of an atom of chlorine. So what does this electronic structure tell us? Sometimes they call it electronic arrangement. Sometimes they call it electronic configuration. So they all mean the exact same thing, whether it's configuration, arrangement, or structure. So what we can say is this is the first shell, and then it followed by the second shell, and then followed by the third shell. As we could see, the first shell and the second shell is fully filled, so the third shell is not completely filled yet, and the third shell is the outermost shell. And how many electrons are there in the outermost shell? So there are 7 valence. If you don't like the word valence, you can stick with outermost, but you gotta know each and every one of these meaning. So therefore, 7 valence electron mean group 7 as told in the periodic table. On the other hand, this outermost shell electron is 1 valence or outermost electrons, therefore this is group 1. As you know, period 3 is the third row of the periodic table. Group 1 is going downwards, is group 1, and they want the formula, they don't want the name, they don't want the configuration, they want the formula. This is a metal atom. Metal will want to lose electrons, so sodium become sodium plus because 281 become 28. You lose the 1 outer shell electrons, and therefore you get Na plus. As for Cl minus, so well, Cl is 287. They gain 1 electron to complete the outer shell. You get Cl minus, which is 288. So it's Cl minus because you gain 1 electrons. This is a recurring example of the type of questions that always come out. They're asking you why the sodium ions and chloride ions are stable. You got to focus on the outer shell. We talked about the outer shell just now. What is the purpose of you gaining 1 electron here? Why not 2 electrons? Why do we lose 1 electron and not any other electrons? Because this was in group 1. So it wants to complete the outer shell by losing these outer shell electrons. So now both the Na plus and Cl minus have fully filled outer shell. This is very, very important. They have a fully filled, or they have a full outer shell, outermost, or I could use the word valence, whichever one you like, stick with 1. They now have fully filled outer shell. Next one is a structure question for 2 marks. You really must know properties of ionic compound. These are in the syllabus. They say candidates, O-level combined science students should be able to state 2 properties of ionic compound, and one of them will be high melting and boiling point, because you are breaking strong ionic bond. But they are not asking for a reason, they are asking for stating, so you don't need to explain because there's only 1 mark for this. And another mark is ionic compound can only conduct electricity. So you do not conduct electricity when you are solid, because the ions cannot move, they are not free to move. They can only conduct electricity in liquid, basically molten state, or when you dissolve in water, or when dissolve in water. When you dissolve in water, that is called aqueous state, aqueous solution, aqueous state. The last bit of this question to get the full 5 marks, why chlorine is placed in group 7. So we know chlorine is 287. This was given earlier in the question, 287. And we know it was a result of the outermost shell electrons. So chlorine atom has 7 valence electrons. Hello again everyone, welcome back to ptet.chemistry channel. So in this continuation of this year 11 revision on inorganic chemistry and the periodic table, I'll be talking about this set of questions that specifically cover group 1 metal chemistry. So group refers to the vertical up and down. So we're looking at group 1 where it labels with the Roman numeral 1 up there. So you will have lithium, sodium, potassium, rubidium, cesium, etc. So rubidium is below potassium. That is the information given. State the formula of the rubidium ion. So being a group 1 metal, All of them would have 1 electrons in the outer shell, such as what I'm showing you on the screen right now. 1 electrons in the outer shell, blah 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 blah, something 1 in the outer shell as well. So therefore, when they form ions, the metal loses electrons and they will form a singly charged cation, meaning to say they will form positive ion with a +1 charge, because group 1 metal loses 1 valence electron, and therefore you get a +1 cation. Rubidium and potassium both react with cold water, so very reactive metal. So how different would they react? So this question is not why or how they are the same, but this is different. So we can say that rubidium is below potassium, and therefore the outer shell is easier to be lost. If the outer shell is easier to be lost, rubidium reaction will be a lot more reactive. Difference in the way that they react. So rubidium would react more violently. It would react more vigorously. So essentially you want to highlight the fact that the reaction is a lot more reactive. So you say more violently or more vigorously. Both of these would imply or would suggest that rubidium is a lot more reactive than with potassium. Somewhere along that line, straight to the point. Okay, now state the products, because this is a metal plus water, or reactive metal plus water. Reactive metals like group 1 metal plus water, you will get metal hydroxide and also hydrogen gas. However, they say state the products, so usually we give the name, but because they don't say state the formula, if you give the formula, I don't see how they will be wrong, because they don't say name the products. So you could say rubidium hydroxide, or you could give the correct formula. If you know how to get to the correct formula, that would have been alright as well. Because of Rb plus, you have OH minus, it will be RbOH. This will be H2 and not H, because hydrogen exists as a molecule. In this next question, so again, they are all elements in group 1 chemistry. Outermost shell mean valence shell. So how many electrons are there in the outermost shell? As mentioned previously, all the group 1 metals, group number tells you how many electrons are there in the outermost shell. Group 1 meaning they all have 1 electrons. Okay, use the word 1 electron, choose whichever one, and you can just get that 1 mark straight away. Next one is describe the trend, not explaining. They are not asking for explanation, they just want what happened to the trend in melting point going down this group 1. So down group 1, this is a stating kind of question, a factual kind of question. We can say that the melting points decreases, or the melting point decrease, but it has to be decreased down group 1. So basically lithium to sodium to potassium, rubidium, cesium, the melting point decrease down group 1. All of them react with cold water, at least lithium, sodium and potassium, they react with cold water. How are they similar? Previously, in the previous question, the question specified difference, where one metal further down become more reactive, they react more vigorously and more violently. Here is how are they similar. If we look at the previous question as well, the reactive metal plus water give you metal hydroxide and hydrogen gas. So the fact that hydrogen gas is produced, you will see effervescence, you will see bubbles, all right? So there is gas being produced. So they say how are they similar? So how they're similar? All of them produce or form, whichever word you like, straight to the point, they give off hydrogen gas. All right, how are they different as well? So all these 3 elements, lithium, sodium and potassium, the way they react with water is they will float on the surface of water. So all lithium, sodium and potassium, they float on water. They react on the surface and they might catch on fire. All right, they can catch on fire. But essentially they float on water. They can catch on fire is probably another observation already, or another similar kind of reaction. They float on water. As they react, then it will get smaller in size, and then the solution will become colorless. Moving on to the next question. So again, it's about lithium, sodium, and potassium. So not too surprising. Hopefully you can see that, group 1 chemistry type of questions, very, very popular. Descended meaning going down. So what happened to the melting point of the group 1 metals down the group, going down the group? Well, it's just stating, so it's not explaining. So we can say that melting point down the group decrease. So it's a trend that you must know, as stated in the syllabus. They get the melting point become lower and lower. Now, why do you call the group 1 metal as alkali metal? If you think about group 1 metal, they can react with water. They can react with cold water. They can react with water, or they can react with cold water to form metal hydroxide. And guess what? Anything that contains hydroxide therefore forms alkaline solution. Alkaline solution means your pH is above 7. Your pH is above 7, is greater than 7. So therefore, it is an alkaline solution because the hydroxide give you the alkaline solution where the pH is above 7. On to the next part, they react with chlorine. Chlorine is a non-metal. If you think about the periodic table, it's in period 3, but there's not what give it away. Group 7, there's what give it away as a non-metal. And they will get ionic metal chloride because metal on the far left of the periodic table, non-metal, non-metal on the far right of the periodic table. You gotta write a balanced symbol equation. Chlorine with potassium. Chlorine exists as Cl2 from your structure and bonding. Covalent bonding, one of the many simple covalent molecule stated in the year 9 syllabus. Cl2 plus potassium. K is not K2 because it's not a non-metal covalent compound. So K, and then they will form KCl. So this is the ionic compound that you get. K plus and Cl minus. So plus 1 and minus 1. When we do cross multiply, we cross multiply the value. So we do not cross multiply the ion or the charge, we cross multiply the value of the charge. So 1 there become 1 there. The value of the charge is 1. So I just bring down the 1. This means 1K plus and 1 Cl minus. So the formula is going to be KCl just like that. Of course, they want the balance equation. I've got 2 chlorine. I've got 1 chlorine. So I put a 2 there. Now I have 2 potassium, but I only have 1 potassium on the far left here. So I need to add a 2 in front to balance my equation. Next one. This is a repeat question from previous similar question. How does the reactivity of lithium differs from potassium? Lithium is 2,1, whereas sodium is 281. This is 2881. As you can see, the valence electron, the 1 electron, is further away from the center of the nucleus, from the center which is the nucleus. Therefore, it's easier to be lost. Going down the group, your valence electron, easier to lose, easier to be lost. If you are easier to be lost, therefore, you are more reactive because you are easier for you to lose electrons. So therefore, lithium is less reactive than potassium because the lithium is further up in the periodic table in the group 1 compared to potassium. This answer will be correct if you say potassium is more reactive than lithium. It's the same way. State one way in which the properties of potassium chloride they mentioned just now is ionic compound. How is ionic compound different from covalent compound? We talked about 2 things previously. We talked about conduction of electricity for ionic compound. Covalent compound does not conduct electricity at all, even when solid or liquid or aqueous, and covalent compound has low melting point. So you can choose either one of these because they say state one way. So I could think about potassium chloride has high melting and boiling point. So potassium chloride has high melting point, melting and boiling point if I want to, but melting point would have been alright as well. But they say differ from, right? So I need to say but covalent compound would have low melting covalent compound will have, or has rather, covalent compound has law, high versus low, melting and boiling point. If you want, you can talk about conduction of electricity. Potassium chloride does not conduct when liquid or aqueous, but they conduct when they are solid. Alright, so potassium chloride can conduct. So I can use KCl, or you can use potassium chloride, whichever one you want. So potassium chloride conducts electricity. Conducts electricity when liquid or aqueous, not when they are solid, but not when solid. But then I also need to mention about covalent compound. So covalent compound does not conduct electricity at all. Covalent compound does not conduct at all, even when they are solid, liquid, or aqueous. All right. In this question number 5, so chlorine, bromine, and iodine, these are non-metals. We know that they are group 7. Specifically, they are called halogens. So they exist as these diatomic molecules. So what is meant by the term diatomic? So diatomic means 2 atoms. These 2 atoms are bonded covalently. So they are bonded, or they are joined together by covalent bonds. So it's very important to focus on the covalent bonds as well as the meaning of the di. That means the 2 atoms bonded together. Describe the trend in color as you go down the group. Down the group is also known as descending the group 7. So that means down group 7, we know that chlorine is a pale green gas. So it's very, very light in color. We know that Br2, so this is at room temperature and pressure, as stated in the notes as part of the lecture tutorials. So these are red-brown liquid. So these are pure element. And this I2 is a gray-black solid. Of course, when these are dissolved in water, this chlorine aqueous solution dissolved in water looks pretty much colorless. This red-brown liquid, when dissolved in water, looks pretty much orange-yellow. And this gray-black solid, when dissolved in water, looks a bit brown solution. In terms of the color of the elements, not the aqueous solution, so the color becomes darker, or the color darkens down the group 7. So darker down group 7. If I just write that very, very clearly, it becomes darker down group 7, it darkens down group 7. The next question, in what physical state do the following elements exist at room temperature and pressure? This is at 25 degrees Celsius. As I mentioned, bromine is a liquid at room temperature and pressure, and iodine is a solid at room temperature and pressure. Just like that, you get the 2 marks available for the question. For part C, this is about a displacement reaction. So what is a displacement reaction? It means that a more reactive halogen. So you have chlorine, bromine, iodine in that particular order in the periodic table. The higher you are in the group 7, you are more reactive. The lower you are in the group 7, you become less reactive halogen. The more reactive halogen will displace the less reactive halogen molecule from the ions. So what we have here is basically I minus, this is called iodide, and what we have here is essentially the halogen, bromine. Bromine is above iodine in the periodic table, so bromine is more reactive than iodine. Therefore, bromine can displace I2 from I minus, also known as iodide. Describe a positive test for iodide ion. This is part of practical, part of qualitative analysis as shown in the lecture tutorial with a demonstration. So we know that we need to add nitric acid first of all. So it's very important that we add the nitric acid first of all, and then, so together, then you must add aqueous silver nitrate solution. So silver nitrate, nitrate is a salt that comes from HNO3 nitric acid. Silver nitrate is a compound, so it contains Ag plus NO3 minus. Silver nitrate AgNO3 as part of year 9 chemical formula topic. In terms of the observation, you will precipitate. So you get a white, sorry, not a white, a yellow precipitate, because this is going to be silver iodide. So your observation, you cannot see the silver iodide, but what you see is the color of the silver iodide called yellow precipitate there. The next question is asking you on why aqueous bromine does not react with aqueous potassium chloride. Well, as mentioned just now, so chlorine is above bromine in the periodic table. So if chlorine is above bromine, chlorine is above bromine. If you want, you can write the words chlorine, but not the word chloride, because it has to be the element, the group 7 halogen. So this is above chlorine. Chlorine is above bromine in the periodic table. So what I can comment about this is bromine is therefore less reactive. So bromine, meaning to say Br2, is less reactive. Bromine is less reactive than chlorine, CO2. Therefore, CO2 cannot, Br2 cannot displace CO2 from Cl minus. That is your observation. You cannot kick the Cl2 up from Cl minus. It does not react. The reason for that is a result of the difference in the reactivity, where reactivity decreases down group 7 as stated in the syllabus very, very clearly. Next question is pretty much similar. You have bromide reacts with chlorine. Again, chlorine is more reactive than bromine. So chlorine can displace bromine Br2 from Br minus to form aqueous solutions of the NaCl and Br2. If I follow the previous equation like this, so that means I can have Cl2 aqueous plus my sodium bromide. Sodium bromide can react with chlorine, and this is aqueous, and this will give me sodium chloride aqueous, and I will also get Br2 aqueous. But just like how we balance this equation with the numbers in front as part of year 9 chemistry content, I have 2 chlorine atoms. Here I only have 1 chlorine atoms, so I put 2 in front. That means I have 2 of that NaCl unit. I have 2 Br there, so again I put a 2 in front of the NaBr, just like I had a 2 in front of Ki and 2 in front of KBr. Here is potassium salt, whereas here is sodium salt based on the question. You still have to balance it. Now this reaction happened because chlorine is more reactive than bromine. Chlorine is above bromine in the reactivity, not the reactivity series, but the periodic table. Chlorine is above bromine in the periodic table. So chlorine can kick out bromine. Chlorine can displace. This is called a displacement reaction. So that means the more reactive halogen can displace the less reactive halogen from the halide. Suggest the color of the solution. I want to focus on this word called solution. So you do not get Br2 liquid. Br2 liquid is a reddish brown liquid as an element. But here you get an aqueous solution of Br2 as stated in the syllabus. Br2 aqueous is going to be yellow-orange. You can say yellow, you can say orange, or you can say yellow-orange. All of them would be acceptable. Okay, so either yellow solution or orange solution or yellow-orange. The color is a lot lighter compared to Br2 liquid, which is a dark reddish brown maroon kind of color. As for part 2, construct a balanced chemical equation. They call it a symbol equation. It has to be balanced. I think I did that earlier already as I explained about balancing the atoms and stuff. You do not need to have the stat symbols. You don't get extra mark for that, but you do get something similar to something that was already presented to you. You know the Na plus, K plus, Li plus, they are all group 1 alkali metal as part of what you learned in the earlier lecture tutorials. So K plus, I minus, Na plus Br minus is still a group 1 combining with a group 7 halogen. You do get a yellow-orange coloration as a result of bromine aqueous being displaced from the bromide, as chlorine is a more reactive non-metal halogen compared to bromine there. Question 6, these are properties of 4 halogens which included F there. So F exists as F2, CO2, Br2 and I2. So we know that chlorine is a gas, a pale green gas. bromine is a reddish brown liquid, and iodine is a solid, a dark gray black solid at room temperature and pressure. This is at 25 degrees Celsius. Can have a look at the melting point and boiling point. If you think about the boiling point, you see the trend. It is getting harder to melt and also boil. So that means the value is going to be higher. We know chlorine is already a gas. This is already a gas at 25 degrees Celsius. So you must already boil, you must already turn to gas way before 25 degrees Celsius. I don't know, you could say, give or take, predict. So this value here has to be sensible. So if you think about the value here, it seems like it increased by around, I don't know, plus 130. So from minus 188 to 59, if you press your calculator, 59 minus 188 negative, because of the minus, it becomes a plus. There is a difference of 249 there. If I divide 247 divided by 2, it's around a difference of 120. So that is where my sensible mathematics come in, give or take around plus 120 or plus 123, plus 122. It's an estimate. Is an estimated value. So you could have, predicted a value that is within that range. I have just gotten minus 68 on my calculator, but I would say as long as it's much lower than 25 degrees Celsius, where it's already a gas, by the time I reach 25 degrees Celsius, you will have been okay. As long as you follow the trend of like plus 100, plus another 100, plus another 100, give or take around that range, should be all right. Based on the trend, this is mathematics, this is physics, looking at the trend. Now, in terms of the density, we see that 4.93 minus 3.12, I get plus 1.81, 3.12 minus 1.56, I get 1.56. So, give or take, we know that density stated in the syllabus, the density of group 7 would increase. The densities increase down group 7. So we can see the trend doesn't differ that much. So give or take, maybe. So in order to go from here to here, I add another plus 1.5, give or take. So 1.56 minus 1.5, so I get 0.06. Estimate, right? Predict, estimate. I don't know the actual value. I'm just looking at the trend and thinking about. I have to add another like plus 1.5, plus 1.4. Should be all right for that 2 marks there. The next question, describe the trend in the melting point as stated in the syllabus. But as you could see, this is already given to you. This is negative. So negative 101 is bigger than negative 220. Negative 7 is bigger than minus 101. So what happened with the melting point down group 7? Describe the trend. So be very specific. Down group 7, the melting point as shown in the table, the melting point becomes higher. It becomes more and more difficult to melt. It becomes more and more difficult to boil. And that is why this is a gas, liquid, and solid there. Deduce the physical state of iodine at 130 degrees Celsius. This is not room temperature and pressure. This is not 25 degrees Celsius. Explain your answer. So we're going to look at states of matter, which is part of topic 1 in combined science chemistry many months ago. So iodine melt at 114. It turned from solid to liquid at 114. It turned from liquid to gas at 184. So we look at the data. I explain first. So iodine melt. So from the table, it melts at 114 degrees Celsius. That was melting point. The boiling point is 184 degrees Celsius. So I talk about the boiling point. Boils at 184 degrees Celsius. So what I can comment on this is that the 130 degrees Celsius is above the melting point. So that means you already melted, but it is below the boiling point. So that means you already melted, you're already a liquid, but you haven't boiled. So if you already melted, but you haven't boiled, so therefore iodine is a liquid at 130 degrees Celsius. This is not room temperature and pressure. Typically, it is a dark gray solid at room temperature and pressure 25 degrees Celsius. By 130 degrees Celsius, 130 degrees Celsius is between the melting point and the boiling point. already melted because it's above the melting point, but haven't boiled yet because it's below the boiling point. Therefore, it exists as a liquid. B part 1, electronic structure, fluorine atom, not the molecule, fluorine atom. If you look at the periodic table, you will see you have got 9 protons, you will see that you have got 9 electrons. If you see the periodic table, this is 2, 7. That is your first shell from hydrogen and helium. This is your second shell, and you are group 7 elements with 7 electrons in the outer shell. Fluorite ion has a single negative charge because we know that fluorine atom, which is 2,7 above, it wants to gain 1 outer shell electrons, and when you gain 1 outer shell electron, it fills the outer shell, and now as each electron is negatively charged, and now it has a -1 overall charge because 10 electrons total, but still 9 protons because you are still fluorine in the nucleus, but you have gained 1 extra electrons. Each electron has a -1 charge overall. You have a -1 charge there. Last but not least, magnesium reacts with excess fluorine. So if I have magnesium plus F2, fluorine as a molecule, diatomic molecule, magnesium fluoride is MgF2, magnesium being a group 2 metal, so they lose outer shell electrons to form Mg2+, as stated in the syllabus. Group 7 form a -1 charge ions, as stated just now. So we look at the valency based on the charges of the ions. Year 9 chemistry, the value is 2, the value is 1. We cross multiply primary school mathematics. This is LCM. It means 1 of the Mg2+, 2 of the F-. So that means the overall formula is 1 Mg, 2 F, therefore MgF2. And we look at the equations. It is balanced, 1 Mg, 2 fluorine atom, 2 fluorine atoms there. This is a year 9 calculation on a topic called reacting masses. So all the lecture tutorials are online. If there were anything you missed out on, you are supposed to practice them. A lot of practice will make you better. So 2.40 gram of that, and you get 6.20 gram of that. So 1 mg give you 1 mgF2. 2.40 gram magnesium give you 6.20 gram mgF2, as stated in the question. What is the mass of magnesium needed to produce 1.24 gram? So what I'm going to do is cross multiply. So when I cross multiply, the 2.40 gram multiply by 1.24, because this multiply with that equal to 6.20 multiply with x. I have just used bracket to represent multiplication. Multiplications, when I move the 6.20 to the other side, it becomes divide. So if I want to show this very clearly, this is multiplication and this is divided by 6.20. Finally, X is the mass of magnesium. That will give me 1.24 gram of MgF2. Press your calculator. 2.40 times 1.24 divided by 6.20. Altogether, I get 0.48 gram of magnesium. So there's 0.48 gram magnesium just for that 1 marks, and rounded up that 8 marks overall question. That's it, ready for work 2, project table. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. I'll see you in the next tutorial video.